Okay, first thing I'm going to do is change the square root to parentheses to the 1/2 power. So notice under the power, we say let u equals -1 plus the ln of 3x. If it helps, put that invisible 1 up there, right? So then when you say du, well, the derivative of -1, it's a constant, so it's 0. The derivative ln of 3x to the first is just 1 over x dx. Well, that's what this is. There's invisible 1. 1 over x dx is the du. And now what we have is u to the 1/2 power. Well, when you integrate u to the 1/2, you're going to add 1. Well, 1 means the same thing as 2 over 2. 2 over 2 plus 1/2 is 3 over 2. And again, when you divide by 3/2, you end up multiplying by the reciprocal. This would be a very good one to memorize. So f of x is 2/3 u to the 1/2, or since it's to the 1/2, you actually can rewrite it as a square root if you'd like, or if you'd like to leave it like this, plus uppercase C. I didn't leave myself very much room. Just like that. All right, this one looks, it's a little bit dicey, but notice this is cube root, so all of this is to the 1/3 power. So you have ln, or let, I was combining, and let u equal e to the 4x plus 4. Remember, when you take the derivative of an exponential, it's the original times the ln of e, but that cancels, times the derivative of 4x, which is 4. And that's what we have on the, so all of that stuff right there on the outside is d, that looks like a dv, but du. All right, and then what we have is u to the 1/3. So we're going to add 1, that's 4/3, and then we divide, we're going to end up multiplying out front by 3/4. All right, so f of x is equal to 3/4 times u to the 1/3, and then inside the parentheses is e to the 4x plus 4, and that should really kind of be a crooked e, just like that. Okay, let's look at this one right here. Cotangent, and there's the theta, -1x. So this is to the 1/2 power. All right, so remember, it's the item underneath the power that ends up being the u. So let u equal cotangent -1x. And then, oh, this is going to be tricky. Well, the derivative of cotangent is negative cosecant squared times the derivative of -1x, which is -1. So that becomes positive cosecant squared x dx. What do you know? On the outside right there. So this stuff right here is all of that stuff. And now what we have is u to the 1/2. In this case, I'm okay with rewriting it as square root plus uppercase C. And we can go ahead and write cotangent -1. I left off the x. The x is very important. Just like that. I realize how crooked I write. So let's try another one. Okay, this one does not have parentheses with a power, so think about that as the parentheses to the first power. So we're going to say let u equal x squared plus 1 du is equal to 2x dx. But here's a problem. That does not match what we have. This says 2x. Whoops. This says 4x. So to get this to be 4x dx, we would have to multiply both sides by 2. So 2 du is equal to 4x dx. And then what we have is 1 over u, because all of this stuff right here now is the u. So f of x, remember it's 2 du, so I can put the 2 out here, and then this becomes, remember the 4x dx is the du, and then we have 1 over u. And remember, what's the integral of 1 over x? It's ln of x, like that. So f of x is 2 times the ln absolute value of u plus uppercase C, and inside the absolute value is x squared plus 1. You might have to look at that a few times, but you'll get it. All right, this becomes, remember this right here is the theta. This is the theta. So it's negative 12x squared secant squared theta. So let u equal the theta. And remember, this is saying secant squared, right? Du is 12x squared dx, but we need it to say negative, so we're going to multiply both sides by negative 1. And so now we have a negative 1, that's what this is right here, that invisible negative 1. And then, so this piece right here and this piece is the du. And then we have secant squared u du. All right, so this is where you have to know your trig stuff. The integral of secant squared is tangent. So negative 1 tangent u plus uppercase C. It can get pretty dicey. Some of these still make me a little bit nervous. All right, I'm going to end it that one and start a new one where we begin definite integrals.